In today's video, we're going to learn about the unit circle. We're going to identify what is the unit circle and describe its relationship to real numbers, find 6 trigonometric functions of quadrantal angles on the unit circle, 6 trigonometric functions of the 6 trigonometric functions of the special angles in quadrant 1 on the unit circle. And then we're going to use reference angles that we learned in the last video to find all the other special angles on the unit circle. So, what is the unit circle? Well, the unit circle is an equation that is x squared plus y squared equals 1. So what that means is any circle whose center is at the origin, so the center of the circle is at that point 0, 0, and has a radius that is equal to 1 unit in length. Okay, so that's a unit circle. That 1 unit could be 1 inch, 1 centimeter, 1 foot, 1 kilometer, 1 hand span. It could be 1 inch. Now, because the radius of the unit circle is 1, we see from our arc length formula that we learned in our last class, arc length is equal to radius times theta when theta is measured in radians. So, for example, let's say I have this angle here, and this is theta. Well, my arc length, which is S, is equal to R times theta. And since R in this case is 1, that's going to be S is equal to 1 times theta, so S is theta. So on the unit circle, the central angle theta radians subtends an arc whose length is also theta. So this distance here that's highlighted in the orange is the same length as theta is in radians. That's kind of cool that happens in the unit circle. And because of that, some cool things can happen. I didn't mean to erase all of that. All right, and so thus on the unit circle, the length measured of the arc S equals the radian measure of the central angle theta. That is, for each unit number theta, there corresponds a unique point called x comma y on the unit circle. Now, how does that help us? So let's say we're looking at this angle theta here. And it says, okay, somewhere that corresponds to this arc length that has a length of theta, there is a point x, y on the unit circle. And that's that dot I have highlighted, the dot that I have highlighted here. That's our point x comma y. Now we can use this information and the knowledge of that unit circle to figure out trigonometric relationships of this point x, y. So how do we do that? Well, if this point here is the point xy, that means I've moved across the x-axis a distance of x, and I moved up on the y-axis a distance of y. So I have, if I want to talk about, so the length of this side of this right triangle is x, the length of the other leg is y, and because this has a radius of 1, the length of the hypotenuse has to be 1. So we have a right triangle. And we can use right triangle trig to do a relationship between the point xy and the trig functions. So recall that if I wanted to figure out the sine of theta, our rule for sine of theta was opposite side divided by hypotenuse. So the opposite to theta would be y. And our hypotenuse is 1. So our conclusion is sine of theta is equal to the y. So if we want to find the sine of theta, I have that point on the unit circle. It's just that y value of that point on that unit circle. Let's erase those highlights. All right, let's say I now want to find cosine of theta. Well, recall cosine of theta is the adjacent side divided by the hypotenuse. So looking at theta, x is the side adjacent to theta, and 1 is still the hypotenuse. So that would be x over 1, which is just simply x. So that tells us the x value corresponds to the cosine of an angle if that point xy is on the unit circle. Make that a little prettier. Okay, so that's sine, cosine, then tangent is opposite over adjacent. So opposite of theta is y, adjacent to theta is x, so that's going to be y divided by x. Okay, so that's how we find our tangent. So sine is y, cosine is x, tangent is y divided by x if the point is on the unit circle. Now, cosecant, this might be a new trig function for some of you. Cosecant is defined as 1 over the sine function. So that means cosecant of theta, when theta represents an xy as a point on the unit circle with a central angle of theta, cosecant of theta would be 1 over y. Secant of theta is defined by 1 divided by cosine of theta. So for the unit circle, that would be 1 divided by x. And cotangent of theta is defined by 1 over tangent of theta. These are called the reciprocal identities. These are reciprocal trig functions. And so that's 1 over tangent, which is y over x. And then write 1 as a fraction, flip the bottom fraction, and multiply. You get x over y. So notice I could have skipped all this extra work here and just flipped over this fraction, flipped over, gives us this fraction. So you can just flip over the fractions. All right, so these you need to know and memorize. So that's our foundation. We're going to be working with these 6 identities here throughout today's lesson. So let's start building our unit circle. So we're going to build our unit circle, and first thing we're going to do to build this unit circle is we're going to identify our quadrantal angles. So our quadrantal angles are angles that have a terminal side on an axis. So if I was doing my terminal side is on top of my initial side, this gives me a 0 degrees, and I have a ordered pair, since again this has a radius of 1. So I've moved the x by 1, but I've moved none up on the y-axis, so that's the point 0, 1. That's also for 360 degrees. And then if I wanted to do 90 degrees, my x is 0, my y is now 1. If I wanted to do 180 degrees, my x is now -1, my y is 0. And then if I wanted to do 270 degrees, my x is 0 and my y is -1. So those are key points on our unit circle. So if you know those ordered pairs, we should be able to find the sine, cosine, tangent, cosecant, secant, and cotangent of any angle on that unit circle. Any quadrantal angle on that unit circle. So let's find pi over 2. So pi over 2 would be this angle here, so it corresponds to 0.01. And remember that the x value corresponds to our cosine. The y value corresponds to our sine. So if I ask you to find the sine of pi over 2, that's my y value of 1. Cosine of pi over 2, that's your x value of 0. And tangent of this pi over 2 is y over x. So that's going to be 1 over 0. Uh-oh, cannot divide by 0, so my answer is undefined. Okay. To find cosecant of pi over 2, remember cosecant is equal to 1 over sine. And our sine is 1, so that's just 1. 1 over 1 is 1. Secant of pi over 2 is equal to 1 over cosine of pi over 2, which is 0. 1 over 0 cannot divide by 0, so that's undefined. And cotangent of pi over 2 is 1 over tangent, or remember that's x over y. And our x value is 0, our y value is 1. That simplifies down to 0. Let's do one more. All right, let's find the 6 trigonometric functions of the angle pi. So thinking of my unit circle here, I remember pi is 360 degrees, so that order pair is -1, 0. So sine is your y value, so that's 0. Cosine is your x value, so that's -1. Tangent is your x, y over x. I said x, but it's y over x, so sine over cosine. So 0 divided by -1 is 0. Cosecant, let me not do it in order. Cosecant of theta is going to be 1 over sine, which is 0, 1 over y. 1 over 0 is undefined. Secant of theta is 1 over cosine of theta, so that's -1. And cotangent of theta is x divided by y. -1 divided by 0 is undefined. Right. Now that we know our quadrantal angles, let's expand this to know our special angles in the first quadrant of our unit circle. So I've only drawn the first quadrant. So this is quadrant 1. And again, so our quadrantal angles is the 0.1, 0 here at 0 degrees or 0 radians. And the other quadrantal angle is 0, 1, which is found at 90 degrees or at pi over 2. All right, so the next special angles are coming from the two special right triangles, the 30, 60, 90 and the 45, 45, 90. So we have an angle that is 30 degrees or pi over 6. It has a corresponding special order pair, where we have the angle that is 45 degrees or pi over 4. And finally, the last special angle in quadrant 1 is 60 degrees or pi over 3. And it has this special thing. Now, how do we figure out these order pairs? Well, you can do your right triangle trig. You can draw a 30, 60, 90 right triangle and use those ratios from right triangles to figure this out. I'm not going to go through that process. You can check it on your own if you want to. How I remember this unit circle, this quadrant 1 unit circle, is a pattern. So I'm going to start at 0 radians, and we're going to look at the sine, which is your y value. So your y value starts at 0. So if I start at 0, I count up 1, 2, 3. Take the square root, divide by 2. Take the square root, divide by 2. Now the square root of 1 is 1, so I'm just going to write this 1 divided by 2 because square root of 1 simplifies down to just 1. That gives you your sine value. So the sine of pi over 6 is 1/2. The sine of pi over 4 is square root of 2 over 2. The sine of pi over 3 is square root of 3 over 2 because sine is equal to the y when it's on the unit circle. Okay, now I'm going to do the x values or the cosine values. Now, starting here at 0 radians, my cosine is 1. So I'm starting at a high number at 1. So from 1, which is the highest on the unit circle you can get, I need a decrease, count down. So I'm going to go 3, 2, 1, take the square root, divide by 2. And that gives you your corresponding cosine values, x values, for those special angles. So again, from quadrantal angles, we know the cosine of 0 degrees is 1. The cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2. And cosine of pi over 3 is 1/2. This right here, you need to memorize. Make sure you can reproduce this and memorize this. If you can do this, you can complete the unit circle. Everything falls back to this quadrant 1. So it's fundamental that you can do this. So I want to find the 6 trigonometric functions of theta, which is pi over 3. Okay, so again, think back to what we just drawn. That first quadrant, I start at 1. 1 comma 0 is my quadrantal angle. 0 comma 1 is my quadrantal angle. And if I want to do pi over 3, I know that is here at 30 degrees. Oh, 60 degrees. Sorry, I wrote that wrong. Is 60 degrees is, here is your pi over 3, or 60 degrees. So I need to figure out my ordered pair for that. And so for sine, I start at 0, so I need to count up. 1, 2, 3, take the square root and divide by 2. And then for cosine, started at 1, so I count down. 3, 2, 1, take the square root and divide by 2. And what I'm caring about on this one is our 60 degree angle, or pi over 3, which is this point. So I figured out that I'm going to use the point 1/2 square root of 3 over 2. So sine of theta is equal to the y value, which is square root of 3 over 2. Cosine of theta is your x value of 1/2. Tangent of theta is y divided by x. So that's square root of 3 over 2 multiplied by 2 over 1, which just comes square root of 3 over 1, or square root of 3. That gives you your first 3. Cosecant is 1 over sine, so to find your cosecant of theta, you flip your sine over, and then you must always rationalize the denominator. We don't want a radical in the denominator. So I'll multiply the top and bottom by the square root of 3, and I end up with 2. The square root of 3 over 3 is my cosecant of theta, of pi over 3. To find my secant of pi over 3, I take my cosine and flip it over, so that just becomes 2. And to find my cotangent of pi over 3, I take my tangent and flip it over, and then rationalize. So it's square root of 3 over 3. to find my 6 trigonometric functions of pi over 4. Pi over 4 would be 45 degrees, so it's going to be this point here on my first quadrant. So I'm using square root of 2 over 2 and square root of 2 over 2. So sine of theta is your y value, which is square root of 2 over 2. Cosine of theta is your x value, which happens to also be square root of 2 over 2. Tangent is y over x, and so anything over itself is 1. Cosecant is flipping over my sign and then rationalizing that denominator, that radical, and simplifying down. So that'll be square root of 2. Obviously, secant will be the same thing. And then cotangent, 1 over 1 flipped is still 1 over 1, which is just 1. All right, we are ready to complete our unit circle. So first thing I'm going to do is I'm going to put in my degrees. So 0, then I have 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360, all the way around the unit circle. All right. Then let's see if you can remember your radians. This time I'd pause the video and try to put in your radian measure by yourself and see if you can get all your radian measures in that we learned in our last video. Okay, let's check and see how you did. 0 degrees is 0 radians. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 120 degrees is 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees is 5 pi over 6. 180 degrees is pi. 270 degrees is 7 pi over 6. 225 degrees is 5 pi over 4. 240 degrees is 4 pi over 3. What am I doing? 5 pi over 3. And then 270 degrees is 3 pi over 2. 300 degrees, 5 pi over 3. 315 degrees, 7 pi over 4. 330, 11 pi over 6. And last but not least, 360 degrees is equal to 2 pi. Whew, okay. So that's getting all of the radian and the degree measures. Now I'm going to do the order pairs. Start with your quadrantal angles. So at 0 radians, I am at the order pair of 1, 0, 1 on the x-axis, 0 on the y. 90 degrees, 0, 1. At 180 degrees, I'm at negative 1, 0. 270, I'm at 0, negative 1. All right, so starting for the x's, I start at 1. So that means I need to count down. So that's 3, 2, 1. Take the square root and divide by 2. That gives me the x values for this point. Make that slightly bigger. And then now to do the y's, I start at 0 degrees. My y is 0. So that means I need to count up. 1, 2, 3. Take the square root and divide by 2. And that's quadrant 1, what we've done. Now, we're going to use our unit, our knowledge of this shading, reference angles to figure out the other quadrants information. All right, so in quadrant 1, let's start with the angle whose reference angle is 30 degrees. Okay, so this is 30 degrees in quadrant 1. Now remember from last video, your reference angle in quadrant 1 is equal to your original angle. So that means my reference angle here is going to be equal to my 30 degrees. Let me highlight that again. So my reference angle here is going to be equal to pi over 6. All right, so what you're going to do is you're going to find in each quadrant an angle who has a reference angle of pi over 6. So if I'm looking in quadrant 2, it would be 5 pi over 6, because from that terminal side to the nearest x-axis is 30 degrees, or pi over 6. So that has the same reference angle. What's cool about that, since that has the same reference angle, it must have the same corresponding order pair. So that means since pi over 6 order pair is square root of 3 over 2 and 1/2, 5 pi over 6 order pair is also square root of 3 over 2 and 1/2. The only difference between these two is I am now in quadrant 2. And in quadrant 2, I'm on the negative x-axis and the positive y-axis, so my x's are negative. So I just put a negative. So it's actually the point negative square root of 3 over 2 and 1/2. And that's it. That's how you find that angle measurement. And now we continue. Now I'm going to move to quadrant 3. And I want an angle who has a reference angle of 30 degrees in quadrant 3. So that's obviously 210. That has that reference angle. So that means this order pair must be the same as my 30 degree order pair. The difference is, well, when we're in quadrant 3, our x's is negative, and we're on the negative y-axis, so our y's are negative as well. So now I ask myself, okay, I need an angle in quadrant 4 who has a reference angle of 30 degrees, and it would have to be 330 degrees, because that has this reference angle. So that means this has the same order pair of 30 degrees, which is square root of 3 over 2 and 1/2. The difference is that when you're in quadrant 4, your x's are positive, but your y's are negative. So it's actually square root of 3 over 2 and negative 1/2. Okay. So now I'm going to try the same thing, but this time I want to find an angle in each quadrant that has a reference angle of 45 degrees. Okay. So from the nearest x-axis to the terminal side, we'll have 45 degrees. So in quadrant 2, it would be here at 135 degrees. So 135 degrees will have the same order pair as 45 degrees in quadrant 2. The difference is in quadrant 1. The difference is that in quadrant 2, my x's are negative. So I need to find an angle in quadrant 3 that has a reference angle of 45 degrees. And that angle would be this angle at 225 degrees. And so at 225 degrees, I have the square root of 2 over 2 and the square root of 2 over 2. But I'm in quadrant 3, so my x is negative and my y is negative. Okay, in quadrant 4, I need to find an angle whose reference angle is 45 degrees. And so that is obviously going to be here at 315 degrees. So the order pair for 315 degrees is also square root of 2 over 2 and square root of 2 over 2. Difference is in quadrant 4, our y is negative. X is positive. Okay, then I move on to my next special angle in quadrant 1, which was 60 degrees. We'll do this in purple. Okay, so in quadrant 1, 60 degrees is here. All right, so that 60-degree angle gives us a point 1/2 and square root of 3 over 2. So I need to find an angle in quadrant 2 that also has a reference angle. So from the terminal side to the nearest x-axis is 60 degrees. And so that would have to be 120 degrees. Erase that. 120 degrees. And so this has the same order pair as 60 degrees. So that's 1/2 square root of 3 over 2. But remember, in quadrant 2, your x is negative, your y is positive. So now I need to find an angle in quadrant 3 that has a reference angle of 60 degrees. And so in quadrant 3, to have that reference angle of 60 degrees, you would have to be the measure of angle 240 degrees. And so that has the same order pair as 60 degrees, which is 1/2 square root of 3 over 2. But we're in quadrant 2. My x and my y are negative in quadrant 3. Okay, now in quadrant 2, I need to find an angle whose reference angle from the terminal side to the nearest x-axis is 60 degrees. And so obviously that's going to be here at 300 degrees. And our order pair there is going to be the same as 60 degrees, which is 1/2 square root of 3 over 2. But in this quadrant, our x's are positive, our y's are negative, so that becomes a negative value. Now, that's actually how this unit circle was developed. This is the unit circle. You're going to need to memorize this. In addition to memorizing this information, something else you'll need to know is which trig functions are positive and which trig functions are negative in each of these quadrants. So if I'm in quadrant 1, my x is positive and my y is positive. So that means sine is positive. And if sine is positive, when I flip sine over, I get cosecant, so it must also be positive. And since my x is positive, that means cosine must be positive. And its reciprocal, which is secant, must also be positive. And then tangent is sine divided by cosine. So if I take a positive divided by positive, that gives me a positive. So tangent is positive and its reciprocal cotangent is positive. So in quadrant 1, all of the trig functions are positive. And there's no negative trig value. So you should get no negative results. Now in quadrant 2, my x is negative, my y is positive. So since y is positive, that means my sine must be positive and its reciprocal cosecant must be positive. Since x's are negative, that means cosine is negative and its reciprocal secant is negative. Now to figure out a tangent is positive and negative, remember tangent is sine divided by cosine, or y divided by x. So if I take my y, a positive, divide by negative, I get a negative. So tangent and cotangent are negative in this quadrant. Okay. In quadrant 3, sine your y value is negative, so that means sine is negative. Its reciprocal cosecant is negative. Your x value is negative, so that means cosine is negative, and its reciprocal secant is negative. Y divided by x, negative divided by negative gives you a positive, so tangent is positive and cotangent is positive. All right, for quadrant 4, your y value is negative, so that means sine is negative, and its reciprocal cosecant is negative. Your x value is positive, so cosine is positive and secant is positive. And then tangent is y divided by x, so negative divided by positive is negative. So tangent and cotangent are negatives. That is your unit circle. Please memorize this and be able to work it. Now I want to show you another way that you can figure out these angles. Now we've already memorized the pattern for that first quadrant. So we know this quadrantal angle is 1, 0. We 1, so we count down. 3, 2, 1, 0. Take the square root, divide by 2. And that gives you those values. Now we can continue on in that process to quadrant 2. Notice 0, so that means I need to count up. 1, 2, 3. Take the square root and divide by 2. Okay, counting up gives us to 1. This case is negative 1. 1. Negatives and positive returned by the quadrant. And so I'm at 1 now, so that means I need to count down. 3, 2, 1. Take the square root and divide by 2. 3, 2, 1, 0. I'm at 0, so that means I count up. 1, 2, 3. Take the square root and divide by 2. Now you've completed all of your x values or your cosine values. Now to figure out your sine values, your y's, my quadrantal angle is 0, so it means I count up. 1, 2, 3, take the square root, divide by 2. Quadrantal angle is 1, so I count down. 3, 2, 1, take the square root and divide by 2. Quadrantal angle is 0. Means I count up. 1, 2, 3. Take the square root and divide by 2. Quadrantal angle is negative 1. 1, count up. Count down. 1, square root of 3, square root of 2. 1, so 3, 2, 1. Take the square root, divide by 2. That easy to memorize. All right, now what if I had not just copied down this unit circle? So let's assume I don't have this unit circle to look at. So on the test, you're probably not going to have this unit circle to look at, or when you're trying to figure these out, when you get to calculus and stuff like that, you're just going to have to figure out whether this is sine of 7 pi over 6. So we got to figure out a way to come up with this. Now how I'd work through this is, first thing you want to do is find your reference angle. So let's figure out what quadrant 7 pi over 6 is. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So we are here in quadrant 3. So I know I am in quadrant 3. I recall from last class that to find the reference angle in quadrant 3, I take the given angle measurement and subtract pi. And I'm going to choose to write pi as 6 pi over 6. And so that gives me pi over 6. So my reference angle is pi over 6. So I go back to my quadrant 1 unit circle for pi over 6. And I usually just quickly draw. This becomes so secondhand to you, it'd be really easy for you to draw it out. And I know my quadrantal angles. So this is the point 1, comma 0. This is the point 0, comma 1. On the x here, we're starting at 1. That means I count down 3, 2, 1. Take the square root, divide by 2. All right. And now 0, I need to count up. So 0, 1, 2, 3. Take the square root, divide by 2. Pi over 6, I know, is 30 degrees. And so that tells me I'm using this order pair. But because we are in quadrant 3, I know my x value is negative and my y value is negative. So this is going to be negative the square root of 3 over 2 and negative 1/2. So now I've got the corresponding ordered pair. Give me some more room to write with. And I can find my 6 trigonometric functions now. All right, so sine is my y, so that's negative 1/2. Cosine is my x, negative square root of 3 over 2. Tangent of theta is equal to y divided by x. So that's negative 1/2 multiplied by negative 2 over the square root of 3. A negative times a negative equals positive. 1 over the square root of 3. Rationalize your denominator. And that's square root of 3 over 3. Positive. And that makes sense. Remember, tangent is positive in this quadrant. Now, cosecant is 1 over sine. So that becomes negative 2 when I flip it over. And to do secant of theta, that's 1 over cosine. So that's going to be negative 2 over the square root of 3. Again, I have to rationalize. And I end up with negative 2 the square root of 3 over 3. And then cotangent is tangent flipped over. And rationalizing that gives me 3 the square root of 3 over 3, which is just the square root of 3. And that's how you find any of the trigonometric functions from the unit circle.